expected value. The expected value of a random variable x is the mean of the random variable x. All right. I've seen this denoted a few different ways. You know, we use mu for mean. You may see this as capital E of x for expected value, but it's equal to the sum of x times p of x. Where p of x is the probability that x occurs. So you would have to go through and say x times p of x for every random variable and its probability, and then sum all of those up. Expected value is important because it's a summary statistic for a probability distribution that can be used as a criterion for comparing alternate decisions in the presence of uncertainty. You can see your book gives a table here on, let's see, there's a profit, the probability, and then they have x times p of x. So this table that's given here, I'm going to put it up here. Two different stock options, I believe, or investments. Okay, so here's option A and option B. So it looks like with option A, there's a chance that you would lose $2,000. That chance, that probability is 0.2. So 20% of the time, you lose $2,000. And then you gain nothing 10% of the time. Your profit is $1,000 30% of the time, $2,000 30% of the time, $4,000 10% of the time. And so over the course of time, the expected value, if we multiply each of these two together and then sum up all the x times p of x for stock option A, is $900. And then there's another stock that's given, and its probabilities. You know, you lose $3,000 20% of the time, lose $1,000 10% of the time, then you gain $2,000 20% of the time, gain $3,000 30% of the time, and gain $4,000 20% of the time. And so, you know, just eyeballing these, in my opinion, if you were just to eyeball these and you see, well, this one, there's only one chance that you could lose money. So this must be the better option. But the expected value here for option B is actually higher. So over the course of time, this would make you more money. So it's not really good to just eyeball a distribution. Expected value gives us a mean that we would expect to get out. So in the long run, option B would be $500 more profitable. So anytime you want to figure out expected value, you have to have a probability distribution. All of these values here, these are our x values, the outcomes. These values here, this is the probability of the outcome. So a lot of times you'll just be given those two, and then to figure out the expected value, you have to multiply the two and then sum up that column. Okay? 7.4 is on the variance of a discrete random variable. All right, the formula for the variance is a little different. The variance of a discrete random variable is equal to the sum of x minus mu squared times p of x. All right, so it's x minus mu, the sum of x minus mu, the mean, squared times p of x. And then, of course, if you know how to find the variance, then you know how to find the standard deviation, because the standard deviation is simply the square root of the variance. There is a problem given based off of that same, I guess, one of those tables, stock option A that we were looking at. Okay, so this is just half of that table. And so this mu right here, do you notice what that is? The mean, that's the what? That's right, that's the expected value. All right, the expected value is the mean of a probability distribution. So the mean is the sum of x times p of x. We figured out the sum of x times p of x was 900. So again, mu is equal to the expected value. That's the mean of the random variable. So to calculate the variance, we have to say x minus mu squared. X is the random variable minus the expected value. So you may want to make yourself a little note that mu here, that is the same as the expected value. So then they took and squared and then multiplied times the probability and got these big numbers here. You can see for this set of data, these numbers are pretty large. Alright, and so after you take the sum of all of those values, you get the variance. The problem in the book asks, what is the standard deviation? Remember, the standard deviation is going to be equal to the square root of the variance. Alright, so we would want to take the square root of 3,090,000. All right, and looks like we would get about 1,757.84. The main thing that you need to remember, though, when finding the variance of a random variable is you have to take the sum of x minus mu squared times p of x. And the mu is the expected value. That's not explicitly said on that problem. It's just there and says, well, hey, you should just remember that I told you that the expected value is the mean of the discrete random variable. And then they use the variable for mu, the mean here, which would be okay instead if you put capital E of x. It means the same thing. Then your book goes through an example, the stock option B, and does the same thing and finds the variance there. So really easy to find the variance and standard deviation of a probability distribution, a discrete probability distribution.